Hi everybody. Today I am going to show you how to design a combined footing using Autodesk Robot Structural Analysis Professional. Here I have taken a PDF copy of combined footing design which I have done in YouTube video and I posted it in EduStube. So from that PDF copy, from this PDF copy, I have to take some dimensions to see what this software is giving us. So let's start. What I'll do, choose new. Click on RC element. Go for RC element, new, click foundations. So we are at right place now, but this is an isolated footing, but we need combined footing. So let's click here. Now we need to provide the basic dimensions and the sizes of the column as well the distance between the two columns from center to center. So let's bring that combined footing PDF page. This is a combined footing having load P1 and P2. Here P1 dead load live loads, here P2 dead load live loads are given. Column sizes are also here given. So we need to take the dimensions of the footing. So we can say approximate, here it is 6.2. So let's take say 7 meters because software will change it. And width, say I put dimension say 3 and depth we can check here through moment. We checked it is near about say 750, but shear checking it is not shown here. By shear checking it will be more, say 90 or 1 meter. So let's assume here 95 or 90. Blinding under the footing, normally it is 10 centimeter. Here it is showing 5, say put 10. Column sizes, what I will do? Check the column sizes here. It is showing here 400 for the first one and 500 millimeter square for the second one. So let's write that 0.4, 0.4. Here it is 0.5. Here it is 0.5. Now we have one important dimensions E2. It is actually between these two columns from center to center. Let's see here approximately how much it is. We'll take very close to that. Say here I can see here where it is. Here 4.5. 4.5. So let's take that 4.5. 4.5. Now apply. We got it. 7 meter, 3 meters, and height is 90. Now we have to go for this one, calculation option. Why to go there? To put some spec, I mean, what is the concrete, say concrete, we want to provide, say 30. Longitudinal reinforcement, we don't need 10, as well 15. We need 20 or greater. Change here grade, it must be 400. Transverse reinforcement, we need 10, 15, leave as it is. Additional reinforcement, remove this as well, remove this all, keep only 20 and 25. So we are done here. Okay. Now we go for reinforcement pattern. What to do first? Footing here, we are not going to change anything. We leave as it is. Here actually say, it says diameter for the first layer, second layer, leave as it is, auto, it will check automatically. And the pier, of course, choose the last one. For this part, if you compare this diagram, then you can see H1, E1, E2, N1 is number of stirrups, E1 spacing between the stirrups, here same thing, number of stirrups, spacing between the stirrups, and H1 it is from the top to the first stirrup, this distance. So let's this distance it is 5 centimeter or say 10. 10. Leave this 20, this also 8, leave here say 4. Here also I need N2, say leave as 5 or 4, it's not a big difference. D1, it is showing here, so just click on 20. Steel type, longitudinal reinforcement of pier. So longitudinal reinforcement of pier, we must need longitudinal reinforcement, not like for transverse. Okay. And transverse reinforcement of pier as for transverse reinforcement. It is done. Now go for dowel bar. Put here yes. Go for here at least say 0.9 or say 1 meter. I want 1 meter. Okay. Here 40 dia. Here diameter for dowel bar minimum 20. 8 pieces of steel. Stirrups put here say 4. So we are done here. Now this one leave as it is. Dowel bar as for longitudinal reinforcement is perfect. Go for shapes. What is that? 90 and 90. There is a 2 hooks, left hooks, right hooks. 90, it is perfect. But here remove it. Sometimes software will not provide hooks if it is not necessary. Click here and put your dimensions 0.5. Now you are okay. Go for dual bar. Leave this as it is. And dual bar, I mean this one also perfect. Click OK. Now we'll go for loading. We have to bring our PDF pages, what it is. Let's go for loading. Here it is 600 and 1000. If we look at here also, it is coming just 600 and 1000. This is for dead load, 600, 1000. So this is dead load. This is say 600 and this is 1000. So we are done with dead load. With these two values, put add. So it is added. Now go for live load. Bring live load values. What it is? 400, 800. 400 and 800. Add this. So we are done. Close it. So we are okay now with this. Now let's go for geotechnical option. So what we will do, we shall bring our this sheets. Here we can check 292 kPa. 292 kPa. Let's put that for stress. 292. Say 29.29. Okay. So it is okay. We are now done. We are done now. With all the information what is needed before analysis. So we did it. Now we can go for start calculations. Calculate. It is done. So what we got? 5.80, 5.10. So 90 depth is kept as it is. Say if we change the depth, say 1.1, because I want to change the width. Say apply. What it says? Calculate. It is giving again 90. You see that? Suppose I want to do some optimizations. Here, fixed ratio, say put here 5.8 and 5.1. Say I want to put at least 1.5. 1.5 ratio. Apply. Let's go for calculations and see what it gives. General is good now. 5.8, 3.9. I want slight less width. So it gives 5.8, 3.9 and 0.75. It's good now. So let's go for checking all the things. Say foundation results, what it is. This is here. Global coefficient, design combination coefficient. You can go through it one by one and check it. Which one matching your requirements. So it is done. If you click here, you'll get this loads acting on the footing. We got it, and the moment my also 6110. Actually our target is to see the foundation node, which is very much important to see, because that's what we will try to see here also, comparing something if it is needed, or we'll see the moment also. So let's check here what actually we need to check. Limit states we are not worried about. We want actually geotechnical design, we don't have data to check. So what we will do, we'll go basically for the RC design. So punching force 2221, very good, 2221. Design load 4196, 4196. Punching force is this. Length of critical circumference 4.36. This is very important. Shear stress 0.69 and admissible shear stress, these must be greater than shear stress. Then we are safe. That's what safety factor is greater than 1. Because this value is admissible, shear stress is more than the shear stress. So it is good. Now spread footing, what we need to see, bottom, we have to see the 270 my and mx 1492, around 1500. This is actually for the bottom, and top it is actually 1367. This moment, this one very close to this 1217 for the top, because here this is actually for the top negative. So here 1367, this is 1217. Okay, now what you will do here, you can see the action in between the two column. Here the negative moment is here, that negative moment here, this one, this is at these positions. So longitudinal reinforcement column here, we are interested to see this. So along x-axis 30, grade number 15, this 15, this 15, but we don't need 15 here, but it provided 15. We need less number, but we need 15. No, we don't need 15 here. Okay, it gives some dowels, it gives 20, 10, this is perfect. Column, it gives something different, so we can do some changes also here. Maybe our selection option need to make some corrections. So what you will do, additional reinforcements, Say here we put 20 to this one. What about the transverse? Transverse, say I am removing this 15. I don't need this 15 for transverse, because by seeing this I can adjust it. I don't need this 15 here, so keep this, but 10 you keep for the stirrups. And longitudinal reinforcement. Oh yeah, longitudinal reinforcement, actually I did not take this. I don't know how it come again. These two already I removed. So you have to be careful for choosing this, otherwise it will select. So put this OK and go for again analysis. Do calculations and look at the result again, what you are finding. So go for RC design again. (41962221) slight changes happened, and this one 27014 all are same 1376, because we got before like this 1217, so it's not a big problem. Column, yeah, look at, I change it. Before it was 15, I don't want, and it was 32, I don't want it. So you can change it and during process. So 20 numbers, 20 diabar, 29 numbers, 20 diabar, perfect. Now 20 20 here, 12, this is for the top, 20 dia, so everything perfect. Now here column pair 4 grade 400 number 10, and here also number 10, here number 10, here number 10, but I don't want this. What I'll do, I think in pair, here you go again, reinforce pattern, I will do here pair, maybe see here, maybe I forgot to choose this, I want to click here 20, because pair I want 20 here. So I don't know why it is not appearing, maybe that time I did not put here. So now it is perfect. Go for calculation again, you will find it perfect now. So everything is perfect now, so it will be nice now, all are okay. This all as it is, no, there is no changes. 20 29 20 12 already we checked it, our objection was here, see now corrected. 4 grade, I mean 420 transverse reinforcement 4 grade 10, this is perfect now, because stirrups again this 420 stirrups 10, this is perfect. Longitudinal reinforcement for 2 columns 8 8 16 and 20 milli, and the transverse reinforcement 10, that is perfect. Now we are okay with our all the values. Okay, so you can change it whenever you feel that you want to change it, so you are okay. Now we need to, do I have anything to say? Let's see that. No. So here foundation reinforcement, which is very important to see. We'll see the section as well as perspective of the reinforcement fabrications. So this is the section, if you look at this, this is this one. Okay, so and this one section we can see that, and here details are there, you can go through it and to see, compare it. So we are not going to check this, Just we are removing this because I want to show this slide bigger. So let's see that. Wow, 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 wow. It's very nice. It's very, very nice. So the two columns, is it looking okay? Perfect. So this is done. Now we can go for this one. What it is? We can go for, say, this one. Drawing. Perfect. Look at two columns, section XX, section YY. So XX section, of course, these two column we can see. When we take YY, we'll see only one column. If you look at this way, you'll see only one column. That's what it is. And all the reinforcement, shape, steel, all are there. So you can check slowly and you will understand everything. So we are done with this. I think that's all for this combined footing. So we can stop right now.